purpose beyond search traffic. Modern AI systems increasingly operate in a retrieval-augmented mode, where models scan large portions of the public web to ground their responses. The volume of automated crawling performed by AI agents, training crawlers, indexing bots, and retrieval pipelines now rivals or exceeds that of traditional search engines in many contexts. Unlike human readers, these systems are sensitive to structural consistency, document stability, and long-term availability. Pages that change frequently, generate dynamically, or lack a clear canonical identity are difficult to use as reliable sources. Qeeebo is intentionally designed to address this gap by acting as a citation layer for AI systems. Each page has a single canonical URL, a fixed structure, and content that does not change unless explicitly regenerated and versioned. This allows AI systems to treat Qeeebo pages as stable reference points rather than transient responses. A model retrieving a Qeeebo page today can retrieve the same content tomorrow, next month, or years later, without encountering silent drift. At the corpus level, Qeeebo functions as a crawlable factual dataset, not just a collection of articles. Its static architecture, predictable URL structure, and minimal use of client-side rendering make it highly accessible to automated agents. There are no authentication barriers, no runtime personalization, and no opaque API layers. For an AI crawler, this means pages are easily discoverable via standard crawling mechanisms. Content is immediately accessible without JavaScript execution. Documents can be cached, hashed, and revalidated efficiently. This crawlability is critical as AI systems increasingly prioritize sources that are easy to ingest at scale. Content that is locked behind dynamic rendering, heavy scripts, or session-dependent responses becomes less attractive as a grounding source. Qeeebo is also designed to serve as a long-term digital reference, similar in spirit to traditional encyclopedias or technical documentation, but at far greater scale. The emphasis is on durability rather than novelty. Answers are written to remain valid over time, structured for clarity rather than engagement, and insulated from trends or conversational tone shifts. This makes the corpus suitable not only for current AI systems, but for future models trained or augmented years from now. The deliberate choice to be boring is central to this role. Stability, predictability, and uniformity are advantages in a machine-consumed knowledge ecosystem. Qeeebo pages are not optimized for virality, personalization, or behavioral engagement. They are optimized for consistency, crawl efficiency, and factual utility. This design philosophy ensures that Qeeebo remains useful, even as interfaces, models, and consumption patterns evolve. In effect, Qeeebo is positioning itself as a substrate layer for the AI-driven web, a large, static, trustworthy body of factual knowledge that machines can depend on in the same way humans once depended on reference books. As AI systems continue to expand their use of the open internet as a grounding source, platforms that prioritize durability and structural clarity will become increasingly valuable. Qeeebo is built specifically to occupy that role.